So this is another redox reaction question, and so you'll be following the whole E Mr. T route. And the first question here is doing this E bit. And this is quite a tricky question, actually. You've got to recognise that you are reacting the manganate ions here with iron ethane diorate. And so to work out this ratio, you'd add these two equations together. So you get FeC2O4 making Fe3 plus 2 CO2 plus 3 electrons. Then that is the ratio that you'd be going with. So actually, you'd multiply this bottom equation by 5, and you'd multiply this top equation by 3 in order to get your ratio. So your ratio of MnO4 to iron is 3 to 5. So you'll need that a little bit later once you're working out the rest. So then it says calculate the percentage by mass of iron ethane diorate in the original sample. So our next step here is to work out number of moles. So let's have a look at the question and see what numbers we've got. So if we look through the whole question, we'll see we've got a concentration of volume of potassium manganate. So we can work out moles of the manganate ions, which equals 22.35 times 0.0193 over 1,000, which will give us 4.31 times 10 to the minus 4. Then we've got to use the ratio to work out the moles of the iron 2 plus that was used. So the ratio here is 3 to 5. So that's going to equal 4.31 times 10 to the minus 4 divided by 3 times by 5. So that gives us 7.18 times 10 to the minus 4. Then, as ever, we have the fact we've taken 25 centimetres cubed from 250 centimetres cubed, so we've got to work out the moles of Fe2 plus in 250 centimetres cubed, which equals 7.18 times 10 to the minus 4 times by 10, which equals 7.18 times 10 to the minus 3. And then this is the step where we've just got to take a step back and look at what we're trying to work out. So we're trying to work out the percentage by mass of that. So our triangle that we're going to use needs to have mass in it. So remember, mass equals moles times mR. So our mass of iron ethane diorate dot 2 water equals the moles of it, 7.18 times 10 to minus 3, times by the mR. Now, are we given the mR of that? No, we are not. You would need to work it out, and when you work it out, you'd find that it was 179.8, and that will give you 1.29, and then work out the percentage by mass. So you've got to work out the percentage, you've got to use 1.29, how much is there, divided by the original impure sample, which is it's up here, look, 1.381. So 1.381, and then times by 100, and that gives you your answer, which is 93.5%. Now, if you had used this ratio here, if you couldn't work out the original one, 7 moles of iron to 3 to 7, then actually a quirk of this question is that it will give you a number of it will give you a higher number than 100%, so it gives you 131%, which the exam board got a bit of trouble with after the paper was taken. So if you did use the ratio given when you're working this out, you do get a number which is actually impossible, which is not great.